Hi viewers, welcome to LMS Solution. Today we are going to see about automatic generation control in two-area system, and that automatic generation control when we controlled by means of first tuned PID controller. Here you can see that this is a two-area system model. The two-area system model consists of governor and turbine and then generator load model, and also the second area also having a governor, turbine and generator load model. Both are going to be connected by means of a tie line power flow. Here we are going to maintain the changing frequency of the area 1 and area 2 always equal to 0. That means we are going to exchange the power between area 1 to area 2 and area 2 to area 1 based upon the change in load condition. Here you can see that you can provide the change in load command here for area 1, area 2, and then based upon change in load command, that we need to maintain that frequency, change in frequency almost equal to 0. For then here we are using that controller. Here they use controller is like integral controller. Here we got to measure the area control error 1 and area control error 2. That going to be processed via integral controller, and then it will be provide the command reference for controlling the del omega 1 or del omega 2. Here in this model we are going to use, instead of integral controller, we are going to use fuzzy tuned PID controller. And then for the data for a simulation for the data for governor, turbine, and then generator load model for area 1 and area 2, and then the remaining parameter R1, B1, R2, V2, the data is taken from this book. You can see that this is the data. This same data going to be used here. So here for governor and generator and load model of area 1, this data of governor, turbine, and generator load model of the area 2. Same data going to be used in the Simulink model. Here you can see that so this is a transfer function for governor and turbine and generator load model for area 1, and this is the governor, turbine, and generator load model for area 2. And then here you can see that here we are using that fuzzy tuned PID controller for both area in order to control this del omega 1, omega 2. No. Here you can see that this is a fuzzy tuned PID controller. We receive two inputs. One is area control error and rate of change of area control error, and it will be processed via as a fuzzy controller. And fuzzy control will be provided three variables like KP, KA, and KD. Here we are multiplying that KP, KA, KD with the error parameter, and finally it going to be added together. Finally we'll get the combination of proportional action and integral and derivative action. That going to be provide the command signal or control signal for that governor not to maintain until omega 1 equal to 0. And also here also we are using same kind of fuzzy tuned PID controller. Here also the fuzzy controller will be receive two inputs, and then it will be provided three outputs, and it will be multiplied with the error signal, and then in some here that three signal output will be summing here, and then it will be provided the control signal for that this governor, and then it will be control this system in order to maintain del omega 2 equal to 0. And here you can see that here we are providing the change in load power. Initially I am going to maintain the change in load power equal to 0.2 per unit, and then here you can measure the detail of del omega 1 and del omega 2. Now I'm going to simulate this one. Here you can see that I'm going to change the time, total time equal to 50, and then I'm going to simulate this one. Now you can see that after 25 seconds the del omega 1, del omega 2 goes to 0. That means change in frequency and change in frequency of area 1, area 2. Again now I'm going to test the model with the change in load condition. That means change in load will be changed from 0.22 to 0.1 at the time of 50 seconds. And then here I'm going to select the model for 100 seconds, and here we have to check the result. Now you can see that the load disturbance occur here, and then after some time it reaches to 0. Del omega 1, del omega 2 reaches to 0 because of load changes from 0.2 per unit to 0.1 per unit. Now I'm going to increase the load from 0.2 to 0.6 per unit, and then we have to check the results. So now you can see that here also you can see that during that load change in condition, so it will be have some disturbance, and then after that it reaches to 0. Here you can see that change in omega 1, change in omega 2 is maintained 0. That means based upon that load condition, that means the frequency error between two area is maintained 0. That means here that power flow will be taken place in between area 1 to area 2 and area 2 to area 1 according with the load profile of area 1, area 2 via that tie line. And next I'm going to show that fuzzy file. This is a fuzzy file generated for a fuzzy tuned PID controller. I'm open that fuzzy file, fuzzy, and then here I'm going to open that file. This having two inputs, error and the rate of change of error, and then it is having value kp, ka, kd, and then here you can see that number of members function used for error, change of error, kp, ka, kd, and then this going to be related with the rules. Here you can see the rules. These are rules. Error, rate of change of error going to be related with the kpk and kd. Once you change this error input value, error in rate of change of error, so you can see the variation of kpk, kd based upon error. This error, right, area control error, that fuzzy going to be vary the value of kp and ka, kd, and then it going to be control this governor not to maintain del omega 1 equal to 0 and omega 2 equal to 0. We can see the value of kpk here. Here I'm going to use on scope not to see the variation of kpk, kd, and then here I'm going to use number of input will be 3 and layer will be 3, and I'm going to connect the value of kp, ki, and kd. So I'm going to click this one and I'm going to submit the model. Here you can see that variation of kp and ka. We will see that small difference while simulating the value. It will be changing based upon that kp, ka, kd value. That controller, that main controller will be control this governor not to maintain del omega 1 and del omega 2. So this is the working of this model. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.